In this lesson, we're going to spend some time talking about how to troubleshoot neighbor issues with the IPv4 Open Shortest Path First Protocol, or OSPF protocol, and Enhanced Interior Gateway Routing Protocol, or EIGRP. Let's use this sample topology to walk through some of the basic steps to follow if you're having routing problems. The first step is for us to determine how things should be. In other words, which interfaces the routing protocol should be enabled on and which routers should become neighbors. Then we decide which subnets should be in the routing tables. Here, routers A and B have 3 interfaces. Router C has 2. All of these interfaces should be enabled. We expect router A to become neighbors with B and C. We also expect A to have routes to 6 subnets in its routing table. Here we have subnets 1, 2, and 3. They're directly connected to the router. The routing protocol should make A aware of subnets 4 and 5 that connect to B. It should be aware of subnet 6 as well, since it's connected to C. We would expect to see this information in A's routing table if everything in this small-scale example were working correctly. Commands help us narrow down any issues. We can first use the show IP EIGRP interfaces command shown here. This command shows us if EIGRP is enabled on all our router interfaces. The command we use with OSPF is show IP OSPF interface brief. This tells us if the OSPF routing protocol is enabled on all the router interfaces. Finally, we can use the show IP protocols command to show us the network configuration commands for all the routing processes that are running on the router. It's possible that our routers aren't meeting the neighbor requirements if routing protocols are enabled on our routing interfaces, but we're still not finding neighboring routers. Let's go through the neighboring requirements for OSPF and EIGRP. First, the interfaces on the router must be in an up-up state. If they're down, they're not going to neighbor. Second, we check to make sure that the interfaces on both sides of each link are in the same IP subnet. The network statements for each router interface must use the correct IP address and subnet mask. We check for any access control lists, or ACLs, that may be configured to filter out the hello packets. Hello packets are what establish neighbor relationships. Neighboring doesn't happen if ACLs are blocking them. Then, we need to verify that the routers on each side of the link have matching authentication parameters configured. EIGRP routers must be on the same autonomous system. OSPF uses process IDs that look similar to the autonomous system numbers, or AS numbers, on EIGRP, but they're different and don't have to match for routers to become neighbors. We need to make sure that the hello and hold dead timers match on both routers for them to neighbor with OSPF. Also, the router IDs in OSPF must be unique. We use the show IP OSPF command to display all of them. This checks for duplicates. If we find one, we assign a unique router ID on one of the routers and restart the OSPF process. We enter clear OSPF and then the process ID. OSPF then reloads and goes through the convergence process again. Next, we check for matching K values, because EIGRP uses these values to determine its metrics. Routers must be in the same area for OSPF. Lacking any one of these requirements could prevent neighboring. That's it for this lesson. In this lesson, we reviewed neighbor issues. We discussed troubleshooting commands to help you narrow down problems. Then we looked at neighboring requirements for both OSPF and EIGRP. These can prevent routers from becoming neighbors and sharing information.